Good afternoon or good morning, everyone. Trust you're having a good day. So my name is Kevin. I'll present about the Measuring Internet Resilience project that we're working on with AFRINIC. I'll give the first part of the presentation, and then Amreesh will give the second part. So can you see my slides?
Yes.
Okay, good. Thank you. What is Africa's internet resilience? So for us who work and live in Africa, internet interruptions or service degradations occur frequently. So many people experience disjointed internet, have a disjointed internet experience. A survey that's been carried out by AFRINIC in 2019 showed that measurements are not commonly practiced in the region. So there's not a lot of data when it comes to internet measurements and causes of internet outages. And because of this lack of sufficient measurements, it's very challenging to accurately determine why exactly these disjointed experiences occur, why do we have frequent outages and downtimes. So together with AFRINIC, we are working on a project which we are calling Measuring Internet Resilience in Africa, or MIRA in short, with two main goals. The first goal is to determine the level of internet resilience in African countries, and we want to do this by analyzing and increasing the number of internet measurement vantage points. So there are a lot of measurements that are happening, but not enough to sufficiently determine what's happening. So we want to increase the number of vantage points which these measurements are being carried from and to. And then we want to present this data in a very simple manner. So whether you're a policymaker or a network researcher or an engineer, you can easily find data related to internet measurements in your area and make an informed decision about which internet service provider might be better for you, or how good or how reliable your provider has been for the past, in the recent past. So we recently have been carrying out this project from about July of last year. We signed an MOU with AFRINIC. We've had several webinars just like this one to engage and update the community. We worked on a white paper that we're about to release very soon, which sort of puts together our thinking about how to approach internet measurements in Africa and determining internet resilience. We've identified a number of tools and metrics that we're going to use to analyze this data. Initially, we want to start with data from RIPE and MLab, at least for the quantitative data, but we do have a plan to incorporate even more data sources. We have deployed prototype measurement infrastructure. We have started visualizing this data. And so far, we have about 29 probes, which we call MIRA pods, in about 9 African countries to date. So why do we want to do this? So we want to provide up-to-date information on the quality of internet connectivity. As I mentioned, we want to provide a very easy-to-use platform for any level of user to understand the type of data they are in relation to the internet connectivity. I want to provide insights into policies that contribute to more resilient internet connectivity. So why is it that maybe one country has a better internet resilience than another country? Perhaps there are policies that are more beneficial that could be integrated in the countries that are not doing so well when it comes to internet resilience. And as I mentioned, we also want to make it easy for users at all levels to make an informed decision. When you're maybe want to acquire internet connection, you'll have very good data about how good that connection has been in the recent past. So what we hope to find out with the MIRA project, we want to find out, how does one ISP compare to another ISP? How do statistics measured using tools match user experience? So we are all familiar with, I'm sure you're all familiar with different measurement tools, but how does that relate to the real internet experience? So we are going to combine, the hard numbers, the quantitative data with, qualitative data in terms of surveys and questionnaires, just to determine, does the data we see from the measurement tools, does that match up with the real internet experience on the ground? We also want to see how countries with different internet providers, different infrastructures compare to each other. We want to see the impact of unreliable underlying internet infrastructures like unstable power, fiber cuts, shutdowns. What's the actual impact to a normal internet usage in Africa? And as I mentioned, what are the policies that actually are beneficial in these countries? Why does one country have a better connection than the other? Is it because there are better policies there? So we've identified some countries to start out for the beginning of the project. We've identified the countries that have active RIPE probes and those that have active MLab servers. Under the project, we have added 2 new MLab servers. We installed one at the Burkina Internet Exchange Point, and there's also one in Mauritius as well, which Amreesh is going to talk about. And we want to carry out a maximum of 5 ISPs per country initially, and then mention the quality, as I mentioned, measure both qualitative and quantitative data, and then measure in-country data. So, for example, what we'd like to see is if a country with several ISPs, how do they compare to each other? And then you can also carry out another measurement of how your ISP, how well it's connected to a neighboring country. So you'll be able to see throughput speeds, round trip times, and other metrics that we're going to explain. Amreesh is going to explain in the next part of the presentation. So a quick mention of the type of devices we're using for this. We're going to use software probes. We've installed a number of them, 21 of them so far. They are simple Raspberry 4 Pis that are running Balena OS, which is a cloud OS. And then we've installed the MLab software client for now, but we are looking at how to integrate the RIPE client as well. We want to start with a couple of measurements. We've started with throughput speeds, which are downlink and download and upload speeds, and also round trip time, and then increase more metrics. And the image you see at the bottom there is sort of the dashboard, which we are using to manage the devices as we bring more of them on board. And we have 21 on board right now. So some of the metrics, quantitative data for RIPE, we want to look at uptime, DNS measurements, MLab, throughput, latency, and round trip time. We're already collecting that. Qualitative data, we want to get more information about actual connections. Where are they? Are they at home? Are they at the office? Is it fiber? Is it 3G? Is it ADSL or something else? When a downtime occurs, we want to get a bit more information about that downtime. Was it a power outage? Was it an issue with the ISP? So that we can have a very good picture of that internet, of that ISP, or the internet resilience of that country over time. So a quick flow chart of how we are handling the data. So we have quantitative measurements. This is RIPE and MLab measurements. We're going to integrate surveys and forms very soon. Then we're going to analyze the data. We're already doing that at a preliminary stage. And then finally, we are going to have a visualization platform which will be open to the public, which would be the Internet Society Pulse platform. So briefly about the Pulse platform, you can go to pulse.internetsociety.org. We are consolidating a lot of third-party measurement data to be presented under that platform there. You can have a look and see what's there. It's going to be easy to use. It will be open to anyone. There's already preliminary data that you can see, information about downtimes and so on. And so the data from the MIRA project will also be visible on the Pulse Internet Society Pulse dashboard. So the countries that we have probed so far. So we have Benin, Burkina Faso, Ethiopia, Kenya, Madagascar, Mauritius, South Africa, and just a few days ago, we added Rwanda and Cameroon, which we are very happy about. So on the last column here is the ISPs where the probes are connected. So I mentioned earlier, we want to do a maximum of 5 ISPs per country to start with. Burkina Faso, we're already looking at 5. Kenya, we have 3. Some countries will only have 1 ISP, for example, Ethiopia. And then some ISPs, we're also going to, we might have to include data for 3G and 4G speeds, because if that's the only connectivity available to the users there, that's what we're going to measure. So for example, in Cameroon right now, the 2 probes that we have there are connected through 3G or 4G modem, and we've just started looking at the data there. So I'm going to stop here and invite my colleague Amreesh to finalize the presentation and give the next part. Amreesh, let me know when you're ready.
Thank you, Kevin. Can you just allow me to share the screen?
Sure.
Yeah. Okay, can you see my screen fine?
Yes.
Okay,
yes.
Great. Thank you, Kevin, for that good introduction. So this project, as you know, it's quite a bulky project. So we decided to break it into different work packages. as we usually a term that we usually use when dealing with research projects. So the first work package which we have started working on is about building the measurement device, which we are calling the MIRA pod, and also the orchestration platform. So basically as Kevin has mentioned, the Balena cloud system, which is helping us to orchestrate all basically the fleet of Raspberry Pis out there. So, and then when we are going to do these measurements, then of course we will be able to carry out the analysis of this work, which we have identified as work package number 4, network performance and mobile broadband resident performance as well. What we do is into another very important component called the Internet Resilience Framework. So data is going to come from two primary sources. Two sources. The first is the primary source of data, basically measurement data coming from the pods. And we will also get data from secondary sources, for example, BGP data or data about an IXP or the submarine cable topology. So all this data will be fed into the Internet Resilience Framework, similarly as DNS data. And then finally, we will have another work package which will be dealing with the display and the visualization of the data. Of course, we have many partners working with us, each of them working on different components. So, what is the Internet Resident Framework? How are we approaching that? I would say rather complex system. So, let's say we are going to measure resilience at a country level. So, I suppose policymakers or even people, the end users living in the country, would like to know what is the level of resilience of their national internet infrastructure. But for this, we have to go in finer details. For example, we'll have to know what is the resilience of the underlying networks, what is the resilience of the critical infrastructure, for example, the power infrastructure or the cable ecosystem, how resilient it is. And of course, we cannot talk about resilience if we are not factoring in market resilience. How is the market structured? How is it equitable? Are people in remote places having access to the internet? So on and so forth. So all these different, I would say, subcategories of resilience has their own set of metrics that we will have to dig into and actually build indicators to actually have a final indicator, which would be the Internet Resilience Index. So the way we are approaching this problem, so here is our data pipeline, or basically also the framework dealing with the different sorts of data. So as I mentioned, we have primary sources of data, which are coming from the MIRA pods. So as Kevin mentioned, the MIRA pods will be installed at the end user level. So for us to know what's really happening on the eyeball networks. So it can be in a fixed network or in a mobile broadband network. That doesn't matter. And this information will be captured in the different databases that we are setting up. And of course, once we have all the information in place, we will start analyzing the data based on the different metrics that we have identified, and also the different analytical tool. We will do the data processing and eventually put this data out there so that anyone can use, for example, through an API or through a graphical user interface. Here we call it the MIRA dashboard. It can as well be, for example, the Pulse system, which Kevin just mentioned about. So diving into the different categories and metrics. So for example, at a country level, we have different sources of data. And the good thing is that a lot of organizations has put their data that they are collecting as open data sets. So here we have 5 categories: security, spam, IXP, the cable ecosystem, and market resilience. For example, security, we can look into what is the level of risk a country is posing to other countries. So what is the DDoS potential of a country? And this information is, for example, coming from Cybergreen. Have a look at all the prefixes that are being blacklisted, so we can give an indication about the spam activity of a country. In terms of IXP is actually a good indicator of how efficient the local internet ecosystem is. Of course, depending on the scale of the IXP, for example, what is the percentage of AS peering at the IXP is a good indicator of the robustness and the resilience of the local ecosystem. So this information can easily be obtained from BGP data, and PCH has also route collectors in many IXPs around the world, which makes it very easy for us to gather this data. Of course, we cannot talk about resilience without talking about the cable ecosystem. So as you know, in Africa, we have most of the countries are connected with the cable ecosystem, but we also have 16 landlocked countries, so that the topology of the physical infrastructure will actually differ from country to country. So many things that we have to factor in, for example, number of cable landing stations. Some countries have only one cable landing station, which can become a bottleneck. And also fiber reach. ITU has a very interesting data set about fiber reach. So I was talking about how inclusive the internet is in some African countries, or how not inclusive they are. So having people closer to, as close as possible to the terrestrial fiber is a good indication of people eventually going to have good connectivity. And then, of course, things such as the concentration towards specific ISOs. So you have, I'm sure, heard about many cases where some governments will take control over some networks, especially during elections. So you can actually calculate the choke point potential of a network, and it is actually important to understand whether or not there is a diversity in terms of exit points in a country, for example, that makes the country more resilient to circumvention. Affordability, as I mentioned, is also a very important factor. You can have a very good quality internet with low latency and high throughput, but if it's completely unaffordable, it is not meaningful. So currently we are talking about meaningful connectivity, because affordability is such an important factor. For the ISP itself, so we can look into the quality of service, which would be broken down into three main components: uptime, throughput, and latency. So this information is actually quite difficult to get. So I would say the only way to get that information is through active measurements, or actually looking at how the different probes that we have deployed out there are actually behaving, we can actually easily find whether or not there has been downtime and what type of downtime that has been there. Throughput, so we can run measurements from the MIRA pods, which is a good thing. But of course, our distribution is quite low. It is not giving us a full picture of all the countries and all the networks that we would like to provide a resilient index on. So that's why we need to complement any missing data with the other open data sets. So the good news is that UCLA speed test has some very interesting open data sets. I mentioned about link resilience. So a network or an ISP itself is resilient if it has a diversity of whether or not one is enforcing or yes, Alan?
Yeah, it looked like you are breaking up, but now I can hear you. Yeah, please proceed.
Okay. Yeah. Sorry for that. And then routing. You have routing security. The coverage, like the coverage of prefixes can easily be calculated, like or actually network operators using router origin validation, so on and so forth. There is an important project that is being led by ISOP called Miners, and they have an observatory for routing security, and they actually give a score to a network about how good they are performing in terms of routing security. So all those indices can actually be incorporated in our framework. Yes. So why do we want to create an index? So I already answered that. It's actually to make it easy for people out there, whether you're a network operator or a policymaker or even the end user, to have some sort of indication of how your network is performing or your country is performing as compared to other countries. And this can actually give good indication to people actually making the decisions on what are the metrics or what are the indicators that they need to improve so that they reach I would say an acceptable level of resilience. How are we going to do that? To compute that composite measure, which is going to be one single number. So of course we are going to assign weights to the different metrics that we are gathering. And how are we going to calculate the weights? So we will rely on the opinion coming from subject matter experts. So it can be network operators or any people involved at the policy level can actually provide some good information about which of the metrics is more important. Of course, after collecting the data for the different metrics, we will, as I said, save them in a database, making sure we remove any private information, because we need to be cautious about handling any type of private information. For example, geolocation data, where the probes are located, we shouldn't have any private information attached to it. Where we have missing data, we need to do a data imputation through different techniques, whether it is extrapolation or arithmetic graph, normalize the data so that we can compare likes. For example, we should be able to compare the resilience of Lesotho versus Nigeria, even if it's two different countries with two different landscape. So we should be able to compare those countries. Of course, we will have sub indices as well that we will aggregate together, which at the end we will aggregate and compute a final index. This is just to show you that we are right now exploring some of the data sets that we are collecting. So we have the 21 pods that has now started to send us some information. And so right now we are getting information about upload and download, and then we're also having the information about the minimum round trip time to the server against which the tests are being run. So we are currently in the exploration phase in terms of what type of data can we get and how can we display that. So this is just a dashboard that we have started building so we can compare, for example, one country to another. But the idea is to actually have this type of dashboard, which would actually give meaningful information to, as I mentioned, to policymakers. We don't intend to make it too to allow any user of the internet to have good information about how resilient their network is, and whether or not they are actually benefiting from a good and performing network. I think that's my last slide. Thank you so much for the opportunity given to us. Of course, we are looking for more partners and funding for this project. So if you're interested to work on this with us on this project, please reach out. We would be happy to talk to you. Thank you very much.
Yeah, okay. Thank you, Kevin and Amreesh, and for these presentations on what is the name again of the initiative? It's called MIRA, and I hope we will have some questions. It look like there's no excitement yet, but I hope that as we go, we will hear from people. So, but before we move on, and because there is no hands up and no question in the Q&A, so I can ask a few questions and make some comments. Yeah, I noticed that ZA, South Africa, was shown that it's not yet up. It's not yet connected. It's not okay. South Africa is not yet. You are not yet collecting data from South Africa, and knowing the density and importance of South Africa in our continental ecosystem, I wonder why that choice. Is it by maybe, is it the lower priorities? How do you explain not having ZA in your initial plan? Okay, even though maybe because we know that ZA ecosystem perform better than people you are looking for. I see Benin, Cameroon, Ethiopia. Maybe you target some places where the performance is known to be low, but if that's the case, please say so. The other comment I want to make also is that yes, the MIRA pod, the MIRA pod is run. Is it the same pod you're using to measure the performance and also measuring the other thing? Because you know that, for example, to collect some of the data on the performance, I don't think the sample pod which will measure, or the one you put maybe at any maybe any residential network or 3G or 4G will give you. So there are some of these pods need to be specially hosted at the dedicated places to give you a good and current data on the network performance, because as you know, the edge, most of the problem is that when you go to the edge of the network in Africa, so what you see probably, okay, will not give you the complete view or how the network are performing. So the question is, do you have, the small pod we put at the edge, then the dedicated pod which has more tools more performance than the normal tools, or is it the same pod you're using? Okay, for example, RIPE has the prop and they have the anchor. So to make it easy, are you also running the same model? Then we have the default prop, and then you have the anchor. And yes, so then maybe first, last one comment or question is, so how do I host one of the pods? Voilà. So I'm done for now. So Amreesh and Kevin, I hope you help me understand. And maybe the other, we can enable other comment, then we can still have one questions. So yes, Amreesh and Kevin, please.
Okay. Thanks for the question, Aline. I'll answer the first one, then Amreesh can answer the other ones. So for South Africa, yeah, we're looking forward to getting some data from there. We sent some devices to some colleagues who received them, I think, last week, and they are just yet to turn them on. That's actually the situation. So as soon as they turn them on, we'll also bring them into the measurement and analysis, because that's a key country to get data on. So that's a main thing. We're just waiting for them to turn the probe on. Same thing in Rwanda. Rwanda, we turned on one probe, but there's another probe that should be turned on. We were expecting to be turned on last week, but I think it will be turned on this week. We just got an email from one of our researchers who's helping us with hosting the probe as well. So over time, as we get more and more people to host the probes for us, we'll be able to incorporate more countries and gather data from there as well. Amreesh, you can answer the next ones.
Yeah. If I also may add on what Kevin just mentioned. So you're right, Alan, about South Africa. But the good thing about South Africa is that they already have a lot of, for example, RIPE Atlas probes, and quite nicely spread in the different networks in South Africa. So we already have a good distribution. And we also have very good data. So for example, UCLA has very good speed test data. So as I have shown in the framework that we are building, I mean, QoS, quality of service, is only one part. To actually calculate the whole resilience, it needs so many other information from other places, which the probe itself is not providing. But yeah, definitely South Africa at the end will be included in our study. So your follow-up question was about whether or not, about that we need to put these probes in different geographical regions. Absolutely, yeah, to have actually good, meaningful data. We cannot put the probe on the backbone network, for example, because then obviously latency and throughput will always be good, even uptime. But this also poses a bit of a challenge, like how to actually penetrate, the remote places of Africa, where power is an issue and also connectivity is an issue. I know many people would rely on 3G. So 3G is fine. So for example, we can have a Wi-Fi modem, which is running 3G, and then we can actually use the Raspberry Pi to run measurement. But then in terms of logistics, it's a bit complicated, but we are trying the best we can actually to have at least maximum coverage in terms of the ASs or the ISPs in a country. Maybe in a future phase, we will look into going into having geographically diverse distribution of probes. Yeah. And I think you had another question about the type of probe. So yes, so right now we are only focusing on the Raspberry Pi, which can host different types of probes, which different types of software probes, and they are all running measurements against a target. That target is usually a measurement lab server that we are also trying to install one in each country of intervention. So So the probes will be geographically distributed on the edge, and there will be one node which will be collecting the tests, or one node which will be used as target. Kevin, you can talk about how to get a probe, please.
Yeah, sure. So we are actively looking for volunteers who can help us to host probes. So our contacts are in the slides, and maybe through Elaine, we can coordinate how we can identify good hosts for the probes. Right now, to be a host, we just need you to, at least have an active internet connection at home with at least one Ethernet port available and a power socket, of course. The probes, as they're configured, they're not heavy bandwidth users. They only carry out, at least for now, 6 tests per day. And these are throughput tests and round trip time tests. So 6 tests is, roughly every few hours, it'll do a test to MLab to determine throughput and then also determine round trip time. And they're not, heavy bandwidth consumers. And, between Amreesh and I, just email us and we can get back to you on how we can send you a probe, especially for West Africa, because we don't yet have probes in that part of the region yet, and we really want to include them. Yeah.
Okay, thank you, Amreesh and Kevin, and for your answer. I see no hands up and no question in the question and answer. So once again, thank you for your presentation. I think this is a great initiative, and WACREN for sure will work with Internet Society to deploy more props and more measurement nodes so that we can have more data. And because part of what WACREN community does is that to analyze some of these data for decision making and all these things. So we will for sure come back to you and select some of the campuses, the end ranks, and host some of the props. So thank you.